This box costs $40,000. And if you want to build a competitive AI data center in 2026, you need 10,000 of them. That's $400 million before you buy a single bolt, pour a single slab of concrete, or pay a single electric bill. Everyone's talking about the AI revolution. Nvidia's worth $3 trillion. Microsoft, Google, Amazon, Meta, they're spending a combined $200 billion a year on AI infrastructure. But here's the question nobody's asking. Where's the profit? Because I've run the numbers. And the economics of owning an AI data center? They're either the greatest wealth transfer in history or the most expensive mistake humanity has ever made. Let's find out which one it is. Let's start with the sticker shock. Capital expenditure, CapEx, for a state-of-the-art AI data center is staggering. The GPUs are just the beginning. You need the servers to house them, the networking, InfiniBand switches that cost more than a luxury car per port, the storage, petabytes of NVMe, flash that make enterprise SSDs look like floppy disks, the building itself, reinforced concrete, redundant power, raised floors, fire suppression systems that use gas instead of water so they don't fry your chips. And then there's cooling. An H100 GPU draws 700 watts under load, 10,000 of them, 7 megawatts, just for compute. Add networking, storage, and overhead, and you're looking at 10 megawatts minimum. Traditional air conditioning can't handle that density. You need liquid cooling, direct-to-chip cold plates, immersion tanks, custom plumbing running through your facility like a hospital's circulatory system. A liquid-cooled AI data center costs roughly $15 to $20 million per megawatt of capacity to build. So our 10-megawatt facility? $150 to $200 million in infrastructure alone. Add the $400 million in GPUs. Add land, add permits, add the 18-month construction timeline where your money is locked up earning zero while technology marches forward. You're all in for $600 million minimum before you process a single inference request. And here's the kicker. In 2 years, those H100s will be obsolete. The H200 is already shipping. Blackwell is here. Your $500 million investment starts depreciating the moment you flip the switch. Capital expenditure is a one-time gut punch. Operating expenditure, OPEX, is 1,000 cuts that never stop bleeding. And the biggest cut, power. At 10 megawatts continuous draw, you're consuming 240 megawatt hours per day at an average industrial rate of 7 cents per kilowatt hour. And that's optimistic. In Virginia, it's closer to 5. In California, it's 12. You're spending $16,800 per day on electricity. That's $6,132,000 per year, just for electrons. And that's before you account for power usage effectiveness, PUE, the ratio of total facility power to IT equipment power. The best facilities run at 1.1 PUE, most run at 1.4 or higher. So, multiply that power bill by 1.4. You're now spending $8.5 million a year to keep the lights on. But power isn't just cost, it's constraint. The US grid is already strained. Northern Virginia, Datacenter Alley, is facing power shortages so severe that utility companies are delaying new data center connections by years. Microsoft just signed a deal to power a data center with a nuclear reactor. That's not innovation, that's desperation. If you can't get power, you can't compute. And if you can't compute, your $600 million is a very expensive brick. Then there's staffing. You need site reliability engineers earning $200,000 a year, network architects, cooling specialists who understand thermodynamics at a level most physicists don't, security teams, compliance officers for SOC 2, ISO 27001, and the patchwork of global regulations. A 1,000-rack facility needs roughly 50 full-time employees at an average loaded cost of $150,000 per head. That's $7.5 million a year in payroll and before benefits. So where does the money come from? There are 3 primary revenue models for AI data centers, and 2 of them are traps. First, cloud resale. You buy GPUs. You rent them out by the hour on your own cloud platform. The
going rate for an H100 on demand is roughly $2 to $3 per GPU hour, with 10,000
GPUs running at 80% utilization, which is optimistic. Most clusters average 60 to 70. You're generating $480,000 per day, $175 million per year. Sounds great, right? Except remember, your OPEX is pushing $20 million. Your depreciation is another $100 million annually if you straight line over 5 years, and your financing costs on $600 million at 7% interest are $42 million a year. You're barely breaking even, and that's at 80% utilization. Drop to 60%, you're losing money. Second, training contracts. Companies pay you to train their models. These are massive deals, $50 to $200 million per project, but they're lumpy. You might have 2 clients this year and none next year, and training workloads are bursty. Your cluster sits idle between jobs, burning power, and depreciation while earning zero. It's feast or famine, and the famine periods destroy your unit. Economics. Third, and this is where the smart money is, inference at scale. Not renting GPUs, selling tokens, running models as a service. Because inference has higher margins, more predictable demand, and stickier customers. But it also requires software expertise that pure infrastructure players don't have. You need model optimization, quantization, load balancing, and a product team. You're no longer a landlord. You're a tech company, and that changes everything. Here's the number that keeps data center CFOs awake at night. Depreciation. In accounting, you typically depreciate server hardware over 3 to 5 years. But in reality, AI hardware depreciates faster than a luxury car driven off the lot. When NVIDIA announced the H200 in late 2024, the resale value of used H100s dropped 30% overnight. When Blackwell launched, H100s lost another 20%. We're talking about $400,000 racks becoming $200,000 racks in 18 months. If you're depreciating over 5 years on your books but your hardware is worthless in 3, you've got a massive accounting mismatch and a cash flow crisis waiting to happen. And disposal? You can't just throw 10,000 GPUs in a landfill. E-waste regulations are tightening. Globally, responsible recycling costs money. Some components contain rare earth metals that require specialized extraction. Your end-of-life costs are a line item most projections ignore, but they shouldn't. There's an economic principle from the 1860s that explains everything happening right now. It's called the Jevons paradox. When coal became more efficient to use, consumption didn't drop. It skyrocketed because efficiency made new applications profitable that weren't before. AI is the same. Every time we make inference cheaper through better chips, better optimization, better scaling, we don't use less compute. We use more. We build bigger models. We run them on more data. We deploy them in more places. Demand expands to absorb every efficiency gain. This means the data center build-out we're seeing, it's not a bubble that pops. It's a treadmill that speeds up. The facilities being built today will need to be twice as large in 5 years just to stay relevant. The arms race never ends. So who actually makes money in AI data centers? Not the people building them as a speculative bet. The winners are the hyperscalers, Amazon, Microsoft, Google, who own the full stack from silicon to software to the customer relationship. They can absorb the capex because they amortize it. Across millions of users, they can negotiate power deals you can't. They can design their own chips, Trainium, TPU, Maya, that undercut NVIDIA's pricing by 40%. If you're an independent operator, your edge isn't scale, it's specialization, niche workloads, geographic arbitrage, building where power is cheap and regulation is light, vertical integration, owning the model, the infrastructure, and the customer, or timing, buying distressed assets when the inevitable consolidation hits and the over-leveraged players fold. The AI data center business isn't a gold mine. It's a gold rush where the people selling shovels, NVIDIA, the construction firms, the power utilities, are making the real money. And the miners, most of them are digging themselves into debt. Before you invest $1 in AI infrastructure, run the numbers, all of them, because the building is the easy part, making it profitable. That's the real engineering challenge.